All right, let's dive in. Today, we're talking about a corner of the cybersecurity world where a data breach isn't just about stolen information, it's about shutting down a power grid or stopping a factory in its tracks. We're talking about operational technology, or OT, the systems that run our physical world. And securing them? Well, it means you have to throw out the old IT rulebook. And this quote right here, it says it all. In the world of OT, the absolute number one unbreakable rule is keep the process running. That one principle, that single focus, it flips everything we think we know about security completely on its head. It's a world where uptime is everything, and every single security decision has to be weighed against the very real risk of a physical shutdown. So here's our game plan for today. First, we'll get a handle on the unique risks in OT. Then, we'll look at the real challenges you'd find on any factory floor. And after that, we'll walk through a modern way to secure these places without causing chaos, from the first look to getting compliant. Okay, let's start with the stakes because they are incredibly high. In the corporate IT world, a security breach is bad, no doubt. But in the industrial world, a cyber vulnerability can have immediate, real-world, physical, and sometimes dangerous consequences. And this is really the core of it, right? We're not just guarding databases and email servers here. We are protecting the very systems that control massive machinery, that manage volatile chemical processes, that keep our critical utilities running. A security hole here could lead to a full factory shutdown, a serious environmental problem, or even a direct threat to people's safety. This chart just perfectly captures that fundamental mind shift. You see, in IT, our number one job is confidentiality, keeping secrets secret. But in OT, number one is availability. The system has to be running, period. Integrity, making sure the data is accurate, that's crucial for both. But confidentiality? In OT, it's a distant third, and that is why you can't just copy-paste your IT security playbook over to the OT side. It just doesn't work. So let's get out of the boardroom and onto the factory floor to see what this really means. Why is it so different? You might be asking, why can't they just patch things like we do in IT? Well, it's complicated. These are the harsh realities. You've got controllers that were certified 15, maybe 20 years ago, and you literally cannot patch them without breaking their safety certifications. You're dealing with special industrial languages like Modbus that your typical IT scanners have never even heard of. And so often you find what's called a flat network. Think of it like a building with no internal walls, where one open door gives you access to every single room. Okay, so that's the theory. But what does this kind of environment actually look like when you get your hands dirty? Let's take a look at a real case from a manufacturing plant assessment. 14. During a completely passive check, and that means just listening to the network traffic, not sending a single risky packet, the team found 14 devices on the critical control network that weren't on any map or diagram. 14 unknown, unmanaged potential backdoors, probably plugged in by someone years ago and then completely forgotten. And here's the kicker. That assessment also confirmed a flat network. This meant that any one of those 14 ghost devices, if it got compromised, could see, talk to, and potentially shut down every single PLC, the little computers that run the machinery on that part of the floor. That is a nightmare scenario, and it's born from a super common design flaw. So, the big question is, how on earth do you fix something this fragile without being the one to break it? It all comes down to a specialized methodology, one that puts safety and keeping the lights on above everything else. The approach has to be incredibly careful. It starts with a safety review to draw bright red lines around the do not touch systems. Then, the real discovery work happens passively, again, just by listening. It's only after all that, and only with the full blessing of the ops team during a pre-scheduled maintenance window, that any kind of controlled active test is even considered. The whole point is to get maximum visibility with zero operational risk. Finding the problems is one thing, but fixing them is a whole other challenge. The key is to make changes at the network layer, so you don't have to touch those sensitive legacy control devices at all. You protect the core by hardening the network around it. And a central concept here is the industrial DMZ, or IDMZ. The easiest way to think about it is like a secure airlock or a checkpoint that sits between the corporate IT world and the sensitive OT world on the factory floor. It makes sure no unauthorized traffic can ever pass from the business network directly to the control network. It's a powerful buffer. So let's connect this back to our real-world case. Remember that remote access point that let vendors get right into the main control system? That was replaced with a secure jump server that required multi-factor authentication. And that terrifying flat network risk, it was totally eliminated by putting in that industrial DMZ we just talked about. These are smart, effective fixes applied at the network level. And the results? The two most critical findings, the ones that posed a direct and immediate threat to the plant's entire operation, were completely fixed in just 2 weeks. But here is the number that matters most to any operations manager: 0. That's how many seconds of production were lost while making these critical security fixes. Not one single second of downtime. Because the fixes were all in the network, the sensitive control systems kept on running without a hitch. Now, fixing things this way does more than just lower your risk. It also builds the exact foundation you need to meet some really tough regulatory demands, which always require more than just a simple automated scan. So what about those unpatchable controllers we talked about? You solve that with something called compensating controls. It's a simple idea. If you can't put armor on the soldier, you build a fortress around them. You use network segmentation and monitoring to create a protective bubble. This doesn't magically fix the old vulnerability, but it massively reduces the chance of it being exploited. And just as importantly, it documents for auditors that you have a plan. And when you take this careful, operations-first approach, you start generating the exact kind of technical proof needed to satisfy a whole host of industry regulations, whether it's IEC 62443 for automation or something like NERC CIP for the power industry. Which really brings us to the final critical question you have to ask yourself. Your physical operation, that is your business. So, is the security protecting it built on a deep, thoughtful, and operations-aware assessment, or is it just relying on a surface-level scan that doesn't understand the risks? At the end of the day, properly securing this kind of critical infrastructure means you have to work from the inside out. You have to understand the operational constraints first and then apply the right controls at the right layer. And that whole process begins by asking the right questions. Thanks for